Okay, good morning, good evening. NVIDIA is here. We have two designs. So can I start sharing my screen?
Hi all, thank you for joining. Let's wait for a couple more minutes before we get started.
Okay, I will share my screen in the meantime, okay?
Okay, perfect, thank you.
Can you see my screen, right?
Yes.
Okay.
Yes,
good.
we can see it.
Okay, so let me know when can I start. Okay, we have two designs. Okay, I will start from the first one, and then someone from our team, will continue with the second one.
So what are those two topics you said, Eddie?
Yes, it's two topics: enhancement of CMIS model management, and the second one it's related to signal integrity and dependency on speed per lane.
Okay, sounds good. We'll start in a few seconds.
Okay.
Thank you all for joining. Welcome to the weekly SONiC community meeting. So NVIDIA will go through two PRs today. I think Eddie is already sharing it. So Eddie, let's get started with the first one.
Okay, excellent. Thank you. So I'm Eddie Kvetne, System Software Architect from NVIDIA, and we will start from the first design, some enhancements that we would like to propose for CMIS model management. As we know, when we are configuring a port with CMIS controllable model, we need to synchronize this process. We need to have a configuration of ASIC side, and then only after then we can start with configuration of optical model. So ASIC side is controlled by port torque agent. When CMIS management to optical model is done by transceiver D in PMON PMON Docker. Okay, so today there is some synchronization between them using hostx ready flag in state DB. And it works in the following way, just to refresh, to refresh to you. Today, port torque agent just set up admin status, port admin status. And when this cycle returns with status OK, port torque agent just set hostx ready in state DB. And actually, this flag is used as a trigger, to start initialization of CMIS state machine. Okay. But we understand that there is some potential problems here that I will explain now. The first one is, as you can see, assumption. Okay, just to remind that a requirement to set to there is CMIS specification 5.2, which requires start of CMIS state machine only when there is so-called high-speed signal already sent by ASIC side. Okay, so this assumption here in today flow that immediately after vendor SDK firmware set admin status to up, ASIC is ready and starts sending this high-speed signal towards optical module. Then actually ports or agent set this flag host TX ready and can start CMIS module initialization. But it is not always true. And the process done by vendor SDK, it can take some time. Okay, and in some cases, actually host TX ready might be set in Redis DB and can trigger CMIS state machine when actually this high-speed signal is not yet sent from ASIC to module. In this case, initialization will fail because high-speed signal is prerequisite defined in the CMIS specification, prerequisite to start initialization of data path. Okay, so it is the first problem that we think exists. The second one is actually admin status can be done also to ASIC port when module is even not inserted, right? So in this case, admin status will trigger sending high-speed signal towards module, and it can cause multiple bad effects like crosstalk to adjacent port and high AMI and high bear, and eventually it can even shorten the transceiver lifetime. Okay, so these are a problem statement that we would like to solve with our current proposal. Okay, so what we want to do? First of all, we want to control transmission of high-speed signal from ASIC towards optical module based on module presence. Okay, and we will see how we want to do it. And then we would like to start to trigger module initialization using CMIS state machine only when this high-speed signal is already transmitted by ASIC to module. Okay, so let's see the proposed flows. Okay, later we will see it in much more details, but in high level it looks like here. So we have indication of insertion and removal event. Okay, let's look at insertion. Okay, from PMON putting information in transceiver info. So port SORC agent will use this information in transceiver info to understand that module is plugged in, and then it will explicitly allow this TX signal. Okay, so it will send to SDK firmware host TX signal using a value allowed. Then, okay, as you can see, still nothing is done, okay, at this moment, because to start sending a TX signal, we need to have also additional criteria, actually admin status up. And only when admin status up is become up, okay, then firmware performs a kind of a logical end, and then it will start sending high-speed signal. Okay, now, okay, so as you can see, it is controllable. now by software. Signal is sent only when optical module is plugged in port, okay? And only then we start sending high-speed signal. Now it is a time to notify port SONiC agent about high-speed signals that started to be sent to module. And here we will have new notification from vendor SDK VSI host TX ready notification event. And in this case, this event will be used as a trigger for setting host TX ready already existing Boolean flag in state DB, and then it will trigger actually a semi-state machine. Okay, so as you can see, this high-level flow, again, we will see more details now. This flow actually provides a solution for two problem statements that I mentioned in the beginning. Okay, potential not negligible time. Okay, to start sending high-speed signal and actually control of this high-speed signal to avoid unterminated transmission. Okay, so of course we keep backward compatibility in mind, and this flow will work only on platforms that want to support it. Okay, so that's the reason that on init port SONiC agent will query capability for this new PSI attribute TX signal enable, and will save support flag. Okay, now when optical module is inserted, okay, so it's existing flow, okay, information and transceiver info. So port SONiC agent, only in case TX signal, this flow is supported, okay, only in this case, it will handle addition or removal of information and transceiver info, and it will instruct vendor SDK. It will actually enable or disable starting TX signal. And then, as I explained previously, SDK/firmware will do a logical end, and when admin status is set to up and TX signal is explicitly allowed, then this signal will be sent towards module. The same is actually stop. Okay, when we have a removal event, okay, this signal will port SONiC agent will instruct vendor SDK to stop sending this signal. Okay, the second signal, host TX ready again. Okay, we will ask about, we will do query capability on port init, and we'll save notification indication of this support, and then later when port SONiC agent will set admin status up or down only in, okay, let's see, if this signal is not supported, actually legacy flow, okay, nothing changed. Okay, so it's exactly the same code. Host TX ready is immediately set in state DB. When this signal is supported, host TX ready, it's actually hardware TX ready. Hardware TX ready signal is supported by platform. Okay, and we encourage more and more vendors to support hardware notification for TX ready signal, because we know that, okay, with moving forward to more advanced modules and interfaces and technologies like bidirectional, it can even take longer, okay, to start to do internal initialization in ASIC and to start sending this high-speed signal. So getting back to here, when this flow is supported on platform, okay, as you can see, nothing is done. Okay, when admin status is changed, okay, still nothing is done, and the port SONiC agent will wait for a real notification, hardware notification about hostx ready signal. And only when this hostx ready signal is sent, okay, so information about that it's delivered as a trap to vendor SDK, and then just regular notification is sent to org agent. Only then we will set hostx ready in state DB. Okay, and then as usual, okay, it will trigger initialization of optical module will trigger the CMIS state machine. Okay, so as you can see, okay, two additional signals, okay, I introduced here. Backward compatibility is kept here, okay, so only platform that want to support to this signal will have these flows, okay, query capability is checked, and legacy flow is actually maintained here. Okay, just to mention, we already pushed this new SI attributes for TX signal enable and hardware TX ready notification. We already pushed it to SI community, and it is already merged in the last version of SI APIs, as far as I remember, 1.13. Some additional information about implementation flows, okay, insertion remove, okay, to same SI attribute, okay, will be set to true or false. Yeah, and more information about platform supporting this new enhancement, not supporting, okay, so it's exactly the same. And even in warm boot handling, in ports org agent, we would like to have indication in state DB completely synchronized with the real status. Okay, so definitely, okay, it will not trigger a reinitialization of CMIS state machine, okay, because for warm boot, actually module is already initialized, but it is just to have hostx ready, reflecting the real status of hostx ready. Okay. Yeah, and here end-to-end flow. Okay, just summarizing all changes. That's it. Any questions, clarifications, please?
Eddie, so is there any dependencies between the CMIS specifications like 3, 4, 5? Like, do we have any dependencies? Let's say a cable has CMIS 5 capability, only those will support any sort of flag.
Yeah, so it's for optical modules which are using CMIS 5.0, 5.2 CMIS state machine. Okay, so nothing new. Okay, no dependency. It is same CMIS state machine. Okay, we're just changing a bit. Okay, trigger to start this CMIS state machine. Okay, to make it, yeah. More realistic, okay, it's reflecting the hardware status.
So just to reiterate, only 5 and above versions will have this capability, or like CMIS 3 or 4 can also work well without any issues with the new changes?
Yeah, okay, so I think, okay, any CMIS specification can be supported here. So again, it's about hostx ready, which is set today by ports org agent regardless of CMIS version, right? Yeah, so we are not changing it. It should work, okay, like today for for any version. I think, okay, today transceiver D handles CMIS state machine according to CMIS 5.0 and 5.2. So not sure regarding early versions, okay? But again, this enhancement is related only for trigger, yeah. And high-speed signal, okay, high-speed signal from ASIC to module is required for, yeah, for this CMIS state machine, I think, from early versions.
Thanks. So does it have any like we've seen some ports like SR 4.2, they take at least 15 to 20 seconds to come up, right? Because data path initialization and all the FSM takes time, like at least 10 to 20 seconds to bring the port up and complete the FSM. So does it have any performance upgrade, or like will it change the boot up time of the module?
Anyway, yes, okay. It's okay. If you say that, okay, initialization takes so long time, okay, so definitely you still cannot start a CMIS initialization, right, for optical module. So now, okay, the longer time, okay, it takes to port, to initialize, and to start sending high-speed signal, the more beneficial, okay, this process, right? Because right now it's you can see state machine is triggered immediately after admin status is returned, right? It's like on the first, right? It's immediately, so definitely it will fail. Okay, so transceiver D will start initializing, okay, and yeah, it will not work in DP init state. It will fail because there is no high-speed signal. Okay, so yeah, this process, this enhancement actually enhance it, okay, and make it more robust.
Yeah, currently we add some delays to like kind of loop around and poll the data path state, whether they are ready and active and all those things, right? So I'm just wondering whether this TX ready will kind of shorten that time period.
Yeah, yes, yeah. So HostX ready, yeah, actually today, okay, it's HostX ready set, but actually it is not HostX ready signal yet, right? Okay, so it's a kind of not true. And now we are trying to solve this, okay, real hardware-based HostX ready, and also to solve the problem of unterminated transmission. Okay, so probably it's might be problematic also to some other vendors.
One last question. So this post TX ready signal from the module is trapped into the PMON or like to, and then only it initiates the FSM, right? So how to know that if a module supports this host TX ready trap, whether it will send that update? Can you go down? There is a no, go down.
Yeah, host
Yeah,
TX
this,
ready. Yeah, it's platform dependency, right? Okay, so ports or agent will
this
ask.
firmware is sending a. Sorry to interrupt. Can you go a little bit down? Little. Yeah, here the TX ready trap is sent from the firmware all the way to your
Correct.
leaders.
Right.
Yeah. So
Oh,
how
okay.
to know that if the module supports, the firmware supports?
Okay, yeah, but it is not about module, right? Okay, it is about high-speed signal which is sent by ASIC towards module, right? So if module is CMIS manageable, okay, yeah, definitely module support on that, okay, and it expect this signal to be sent by ASIC firmware. Okay, so when here you're doing query capabilities, you are asking SI, and actually, okay, SI SDK should know if ASIC supports this asynchronous notification of TX ready. Okay, it has nothing to do actually with module. It is about signal sent from ASIC to module, right? So if this functionality is supported, okay, then SAI will report about it. If not, okay, it will be just legacy flow.
So this is not applicable for copper DAC, only for optical cables, right?
Yes, I think you are right. Right. Okay. So semi-state machine, it's for optics with paged memory. Okay. Yeah. So this high-speed signal is prerequisite for semi-state machine. Yeah, I think it for optical, mainly for optical, only for optical. Okay. Any other questions? Okay. If not, we will move to the second. I will design. Okay, I will stop sharing. Tomer, are you here?
Yeah, let me share my
Okay,
screen.
so please start sharing.
Let me know when you can see my screen.
Yes, we can see.
Okay.
Go ahead.
Okay, so the topic we're going to be discussing today is the port signal integrity per speed enhancement feature. So let's just start off with some motivation for this feature and then dive into the design details. Okay, so today the functionality to apply port signal integrity configuration is already implemented in SONiC. However, some vendors want the ability to set the SerDes signal integrity based on lane speeds in order to optimize the way they configure their SerDes. In other words, the current SerDes configuration is determined only by the plugged-in module, regardless of its lane speed. And yet tailoring the configuration to account for lane speed differences may lead to improved performance for certain vendors. One moment. Okay, so these designs aim to enhance the current AC configuration by introducing two additions. The first one is the ability to support different port signal integrity configuration for different lane speeds. And the second one is adding new SI parameters to the existing set of supported parameters. Notice that throughout this whole design, we've kept backward compatibility in mind. So vendors that wish to keep configuring port signal integrity regardless of lane speed won't need to make any code changes, and the code will work properly as is. Let's dive a little deeper into the details now and take a look at the new SI parameters being added to the existing set of supported parameters. Here we can see the 6 new SI parameters that are going to be sent to firmware to configure the ASIC. For each new parameter, we can see its name, we can see the valid values it can get, and what this parameter means. These 6 new parameters are going to be added to AppDB. Here we can see also the corresponding SAI attributes for each of these parameters. The SAI community have already approved the addition of these attributes, and they were merged into the SAI port H file. Any questions so far? Okay, so now let's talk about the JSON format for the SI parameters. In order to send these parameters on to SAI, we are going to use a JSON file called MediaSetting.json. This is not a new file, but it is going to have a new format to support per speed enhancements. So let's take a look at this new format. Under the port media settings, under this block, for each individual port, we can see the SI value structured in 4 hierarchy levels. The first one is the vendor key or media key level, which will be discussed soon. The next one, the second hierarchy level, is the lane speed key, which indicates the port speed and the lane count for that port. On the next level, we can see the SI field names. And on the last hierarchy level, you can see the corresponding values. This updated format of metasetting JSON is exactly like the current format, except for the second hierarchy level of the lane speed key, which was added to the JSON to support pair speed enhancements. Sorry. It will be explained soon, but it's important to mention that here that the JSON parser will know how to handle both the original and the current format JSONs, which means that vendor who wish to stick to the current format of metasetting JSON will not have to change anything in their code or in their JSON. Okay, so how are we going to use this JSON? Here we can see a flow that we'll refer to as the notify metasettings process. This flow describes how SONiC sends port signal integrity parameters to firmware. Except of the changes represented by the red blocks, it is not a new flow, but let's just, to get some context, let's go over it real quick. Okay, so we are in transceiver D daemon inside PMO Docker, and the module was plugged in. As we can see in the beginning, there are some database updates. CDB is being updated with module information and some DOM statistics. After that, metasetting JSON file is accessed to get all relevant signal integrity data. And when first the key is generated for performing the lookup in JSON, and then we're using this key to perform the lookup to get the actual SI values that are going to be eventually sent to firmware. After that, a function called notify metasettings is being carried out. This function takes these SI values that were extracted from the JSON and writes them to the AppDB. Ports occasion listens to changes in AppDB. So after notify metasettings is done, ports agent is triggered. It iterates over all key value pairs that were written into AppDB and uses a method called parse port config to create a port config object, which is some kind of a vector that will store all signal integrity values. Then port agent calls to the method get port service attributes that creates a mapping between the signal integrity values written to the port config to the corresponding site attributes. Eventually, the method set port service attribute will send this mapping to SI using SciPort API. Any questions about this flow?
Oh, I have a question about the speed. Can you go back to your JSON file?
To what? Excuse me?
The JSON file. What is this tool? You know, GAUI 4 and 8. What does it mean?
I'll explain it later, but in general, this is the lane speed key. It is composed of the prefix speed colon, and then this 400 GAUI 4 means port speed of 400 gig with 4 lanes. That's it. This string is taken from the semi spec. I'll get to it later.
That is the complaints from.
Yeah, go ahead. Yeah. No, I saw usually like it's going to be, you know, the lane speed either, you know, 100 gig SerDes or 50 gig SerDes or 25 gig SerDes, right? So, I mean, are we using that convention to name the speed or using this, you know, GAUI 8? Do we have a, I mean, is that industry standard for naming those speeds?
Yeah, it's taken from the semi spec. Actually, it's going to be exactly like that. I'm going to show later how this key is calculated, and I think you'll understand why it's like that.
Okay.
So I believe that is taken from the complaints from the EEPROM, right? From the module EEPROM. So so does it like only CMS supported capable cables alone can be done using this format?
Yeah.
Okay. So and if we change the speeds, right? Like some cables can be like acting as a 400 gig or 100 gig or like even 50 gig, right? So that case, like you need to have entries for each and every speed level. I mean, like 4-lane or like 2-lane, kind of. You'll have different
different
post,
different
pre,
lane,
and main. Okay.
yeah, different lane speeds are going to have different SI values. Yeah, that's the main point of this.
Do we have a concrete example? Like what use case do we have here?
What do you mean concrete example?
What is a concrete example? You know, what for example, like is this like using a 400G QSFDD cable, but we want to use the cable to carry like 100 gig speed? Is that the use case, or?
Can you repeat that? I'm not sure I got your question.
I mean, what exactly is the use case for, the cable to have a different speed? Usually this is not for the optics, right? So for optics, usually they can only carry one speed.
No, we can have multiple options, right? Okay, so you can see here, for example, interface type 400 GAUI with 4 and 8 lanes, right? Okay, so it means that it will be different speed per lane. And in this case, okay, we can have different signal integrity values per lane.
So this is mainly for the DAC cable, right? So, or is this for optical module as well?
I think it's for optical module as well. Yeah, anything. So it's what we want to put in in JSON file, and match will be done with interface type from EEPROM.
Gon, I think you can use
example,
you can use different models. One model can be 100 gig, another model can be 50 gig, and another model can be 25 gig. Because it's the same form factor, you can put different models. And for different speed, you can.
What do you mean? I mean, I think the DAC cable is the same, right? So here the cable type is the same, right? So it's the same, like the QSFP28, right? So yeah.
Yeah.
I mean,
but you will have, let's say, 4 lanes.
Cable. Yeah, go ahead.
You can have 4 lanes 200 gig or 4 lanes 400 gig, depending on your lane speed.
Okay.
Okay, so let's move on. If there are no other questions. Okay, so let's take this flow now as a black box and just mention when it is carried out, when this flow is carried out. So today it is invoked only at the initialization phase of transceiver D and when a module is plugged in. Once the SI per speed enhancement goes live, the SFP state update task thread will listen to changes in state DB. And whenever it identifies port speed change, it will invoke the notify media setting process for that port. Re-invoking the notify media settings process is, in this scenario of port speed change event is essential because when there is a port speed change event, the lane speed changes accordingly. And because we want to send signal integrity parameters based on lane speed, and the SI values we will use to configure that port are now going to be different values. And we will access another entry in the JSON according to the updated lane speed. Okay, now let me share the changes that I think are needed to support the new mode. So the first one is changes to SFP state update task thread. As mentioned earlier, in order to be able to perform the lookup based on lane speeds and to trigger notify media settings process in the scenario of port speed change event, two things should be changed. So first, this thread needs to hold some dictionary that maps between ports to the port speed and lane count. And second, this thread will listen to state DB, and upon speed change event, this port the port will store the port speed and the lane count in the dictionary I've just talked about, and the notify media settings process will be called again. So that was about the first change in that thread. Another change, it is actually two changes, required to support the notify media settings process. First, we need to extend the key used for the lookup in the media setting JSON file. So lane speed will be considered as well. So currently there are two kinds of keys: vendor key, which is composed of a vendor name and a part number, for example, Amphenol 1234. And there is another kind of key, which is the media key, that is composed of media type, media compliance code, and media len. For example, this one. In the updated format of media setting JSON file, the get media settings key method will return 3 values instead of the 2 values described. The additional value that will be returned from this method will be the lane speed key. For example, 14 GAWI 8, where 400, excuse me, refers to the port speed and 8 to the lane count. So now let's talk about how the lane speed key is calculated. So each module contains in its EEPROM a list called application advertisement, which is a list of all speeds supported by the module. For example, you can see here the list. It is taken right from the EEPROM. So we will be using this list to retrieve the lane speed key. We'll go over this list and return the item that its port speed and lane count match these values of the relevant port, which are stored in the dictionary described earlier, the new dictionary, that stores the mapping between the port and the speed and lane count. There is an already existing method called getSIMS application desire that does exactly that. So we'll use it to calculate the new key. Okay, that was the first change for generating the new key. Another change required here is a change to perform the lookup in the updated format JSON. It is going to happen in the get media settings value method that is going to be modified to enable lookup in both the extended format and the current format JSON. So let's take a look here. Once the key is okay, so after we calculated the key, the lookup in the medicine JSON file will be performed. Today, the vendor key, as we can see here, is looked up first, and if there was an exact match, then those values are fetched and returned. If the vendor key doesn't match, then the media key is looked up, and if there is a match, then these values are fetched and returned. That's what happens today. After applying the port hyperspeed enhancement, the lookup will have to support the new lane speed key to support per speed SI parameters. We can see the updated flow of the parser in this diagram. I'll explain it in a few words. So the parser still starts off with searching for the vendor key or media key, but instead of just fetching these values in case of an exact match, it will first check whether the JSON file supports signal data parameters per speed or not. In cases where the JSON file does not provide such support, the values will be obtained from the existing hierarchy level. However, if the media setting JSON file does support SI parameters per speed, we'll proceed to search for the lane speed key in the next hierarchy level and return the corresponding values accordingly. If no relevant values are found, an empty dictionary will be returned, just like today. That is determining whether the JSON supports per speed SI parameters or not will be done by searching for the presence of the string speed colon in the relevant hierarchy level, which is the prefix of each lane speed key. This determination is essential to ensure the compatibility of the code with vendors that wish to keep their JSON in the current format. Again, it's important to mention that this updated lookup mechanism maintains backward compatibility. The parser is capable of handling both JSON of the current format and of the new format, meaning JSON that contains the lane speed key and JSON that don't. You can also take a look at the code for the updated parser attached here. And as for the last change I'm suggesting, it is the changes to the ports occasion. the current data flow described earlier between AppDB and SI should be extended to also include the new 6 SI parameters added to AppDB. That's it. Any questions about the changes?
Yeah, so I think can you go back to StateDB, the port speed? Do you know like when that will be published? Trigger what event will be published? The StateDB port table. You listen to the changes. You're saying,
Yeah.
Is that when the port is up you get that change, or when the StateDB port table will be changed?
It is going to be the listening is going to be added right at the beginning of the transceiver D. So I guess once
so
the
this
port
is
up,
StateDB, right? So the
yeah,
StateDB
StateDB
usually happen. Yeah.
Yes, on port going up, yes, operational speed is updated in StateDB.
So would there be a chicken and egg problem? Say, in order to, let's say change to like a 200 gig lane, you actually need to change the SI first in order to bring up the port. If you don't change that, still use like 100 gig 30 lanes SI parameter, then you wouldn't be able to bring the port up. Therefore, you wouldn't be able to get the StateDB port table change because the port will not be up.
I'm not sure I got you. Once
we can check, okay, StateDB, okay, if it is only on operational status up and or it also okay when administratively port.
So, Eddie, my understanding
status
on the
operational.
same lines Gohan asked, right? So I was under the impression that once you change the speed, then obviously your complaints from the whatever the EEPROM application advertisements related entries will be there in the JSON. So I was under the impression that once you give from the admin user says like speed 1000 or like a 10,000 or like a 10 gig or something like that, right? Then it matches to the corresponding how many number of lanes it needs for supporting that speed. Let's say if a user configures 100 gig, right? So it needs, let's say, 2 lanes or like for energy 4 lanes, let's say, for example. I was under the impression that it will be based on the speed that we set from the user end. Even though all the capabilities are there, finally, when the user selects a particular speed, it will map that entry and then program in the media settings.
it looks like you understood. Once the user changes the speed, it's going to be stored in the new dictionary that maps between the port and the port speed and lane count. And right after that, the notify family settings will be called, and going over this list, the application advertisement list, checking which entry of it has the same number of lanes and same port speed, and that's what it's going to choose for the lane speed key.
Then Gohan's question of the chicken and egg problem how it will be even applicable then. I'm just trying to understand how Gohan's question will be applied here. Like, how do you translate that basically? Okay,
so the question is, okay, when speed is updated in StateDB, because change in StateDB is actually trigger for notify media setting, right? And to make sure that there is no changing. Okay, so we will check it offline. Okay, to make sure that there is no any loop here. In the meantime, okay, what we saw it should work well. Yeah, but we will double check it again. Yeah, when exactly update and StateDB is done and it is done in correct order.
So that's one question. Other question, I think sometimes I think you mention like a 4 lanes, 8 lanes, right? So for example, if you're changing from 8 lanes to 4 lanes, do you actually delete some of the AppDB entry, like extra lanes? Do you delete them? or it just overrides?
It just overrides
Do you
them.
have a delete operation? For example, you have A lens, right? So therefore, you have parameter for each of the A lens, currently, in the FDB. And if you change to 4 lens, I guess you will override the first 4 lens. But what about the extra 4 lens? Do you delete them in the FDB?
I don't think we delete entries from the FDB. I can check that. I'm not sure.
Yeah, but whenever speed per lane changed, yes, we will run notify media setting again. Okay, so only change. Yeah, only change of port speed will trigger the process. Yeah.
But you should delete extra lane parameter if they are not applicable to current setup, right? So.
Right.
Okay.
So one other question, ADN team. So, like for a particular vendor, right? Normally, what we get is like the all the pre-post main values for whatever speeds and different types, right? Like optics or like copper DAC. So with this change, then the vendors should also giving us for different lane count type. Is that a correct statement? Because currently we apply the, let's say for example, even though I break out into 400 gig, I apply the 400 gig copper or optical values, the pre-post main values. So currently based on the lanes used, we are going to change the behavior, right? So then the vendors should be also giving us based on the lane count as well, the values,
If they're willing to configure service based on lane speed, they should, yeah.
Currently, do we have any cables that support that kind of options?
You mean same speed with different
lane speeds? Like currently we are talking about, like, let's say, okay, I'm going to use only 4 lanes, so use these pre-emphasis settings to apply to the media, right? So likewise, like, do we have what cables that we use for testing? Like, I'm just to understand and check with our hardware team and see if do we even have this kind of options in the cables that we use.
Okay, we will check with our PHY expert. Okay, which type of models we are going to use.
Okay.
Yeah.
Okay. So now let me just mention the unit tests I'm willing to do. We don't have much time, so I'll get to it quickly. Okay, there are going to be 3 tests. The first one will be expanding the already existing test called test get media settings key. This test verifies that the key used for the lookup in the media settings JSON file is generated properly. We need to expand this unit test to make it take some dictionary that stores port speed and lane count for some port, and verify that it also returns a valid lane speed key. Okay, that was about the first one. Another test will be a new test called. Okay, this will be a new test that its purpose is to verify that the JSON lookup works properly with both the JSON of the new format and of the current format. In this test, we will
maybe there's one thing I think maybe we should discuss, because I saw there are some changes went into the SERDES setting, that basically when you change the SERDES setting, you have to bring the port down, right? So they have to bring the port mean down before they change the SERDES settings.
You're talking about port toggling in this diagram? Yes. Okay,
yes,
so
I'm talking about some changes went into. I'm talking about some changes went with the port syncing. Oh, sorry, port syncing in the org agent. So basically, they need to change the port. You need to bring the port mean down, right? So Yeah, I think here, right? So you have that. I think that one I'm trying to understand. Okay, so your flow, right? So if you change the speed, you bring the, you bring the link. I don't know. I mean, you bring the link down and up, and then now you apply the 30 settings. You bring the link down, up and down again. Like twice. No.
I mean, only if the admin was up prior to sending the certus to firmware. Only then it's going to be sent.
Yeah. Even in that case, right? So if the port usually admin up, you change the certus, right? So I think we should only bring the port down once, right? So we shouldn't bring the port.
It's only once. Yes, only once.
So
right,
therefore, you need some coordination between the speed change and certus, right? So you should somehow coordinate these two efforts, they to avoid this, the port to be flapped twice.
No, there is already some handling in ports or occasions. So today, for example, port toggled, okay, when speed is changed, when auto negotiation is enabled or disabled, or FAC set, okay. So there is already some handler in ports or occasion doing it only once.
So I think, okay, all right. So I think we need a integration test to verify that the port only flap
once.
once.
Only once. Yeah, good. Okay, so Tomer, please add to test units, okay, to make sure that port is toggled only once when signal integrity parameters are applied.
Noted. Okay.
Okay, we'll do it.
Okay, so we have 3 minutes left. So the test, the second test, as I mentioned, as I started to explain, is to test that the lookup is working properly with both JSON of the current and the new format. We'll take two instances of the same media setting JSON file. They will contain the same data, but one JSON will be of the current format, and the other one will have the updated format, and that contains the hierarchy level of the lane speed key. There should be matching both, and same SI values will be returned from this lookup. This test ensures that the parser of the media setting JSON file can handle both the updated and the current format JSON, and that it maintains backward compatibility for vendors that wish to keep configuring ASIC SI regardless of lane speed. That's it. And the last test is going to be the expanding the ports or occasion test to verify that the SI object is created properly with the new SI parameters. In this test, we will use an instance of media setting JSON that contains all new SI parameters for a certain module, then call to notify media settings to post its data to AppDB, and verify that port occasion manages to create a SI object with all the new values. And that's it. That's it for me. Any questions? Okay.
If someone has questions, okay, please put on GitHub. Okay, there are 2 links to 2 designs and meeting invitation. So yeah, please put, and we will respond.
Okay. Yeah, thanks, guys. Thanks a lot.
Okay, thank you very much.
Bye-bye.
Bye. Hey, sorry. Okay. Is anyone still in this meeting? I just left a message for this Thursday meeting. So we will add 1 more slot from now until end of October to cover more HLD. So I will send out the meeting invitation. The same meeting, the same Zoom meeting will be used for the Thursday meeting. So that slot is purely to cover more HLD review. So just let you guys know. Thank you, folks.